Hello everyone, I hope you are doing well. So in this video, we are going to discuss Leetcode problem of the day, and today's problem is minimum 1-bit operations to make integers 0, and it is going to be a hard level problem. So I was not able to make the video yesterday, and the reason was I was actually traveling. So if it ever happens that I am not able to upload the video, then you can check out my GitHub repository during the evening or during the night, because by that time I would have probably uploaded the code. So if you want to have a look at it, you can look at it there, and the links to the repository are always in my description with all the problems, so you can check them out. So for this particular problem, I would say this was an interesting problem, and not a very easy problem, and you see the code is very small, but it will take you some time to realize how you have to solve this problem. So it says that for any given integer n, we have to transform it into 0 using the following operations. So the first operation is we can change the rightmost bit or the 0th bit, right? And to change the ith bit, we have to make sure that the I minus 1th bit is set, and all the bits from 0 to I minus 2 are not set or they are equal to 0. So basically, if I am at this particular position and there are certain number of bits after it, if I want to change this particular bit, this has to be 1 and all of this has to be 0, right? And for to change this particular bit, I need only one operation. I can change this particular bit in one operation to any bit I want, right? And eventually whatever number I have to make it to 0, right? The whole of that means all the bits should be 0. So let us start how we can solve this problem. First of all, you will realize that for the rightmost bit, you can always do, let's say this is the 0th bit, you can always do one operation, right, to change this particular bit. Now let's say this bit is 0. So this is the first bit. What are the number of operations required to make this particular bit equals to 1, right? So in this case, it is very easy to see. You can change this particular, let's say this is also 0. You can change, first of all, you can change this particular bit to 1 and then change this particular bit to 1 as well. So it took two number of operations. Now let's say this is the second bit. This is also 0 and let's say this is also 0. So starting from 0, how many operations is it going to take you? So we just saw that to reach this particular configuration, it took us 2 steps, right? Now in the third step, I can make this particular value 0, and in the fourth step, I can make this particular value 1, right? So you see this bit was 1 because I wanted to change this particular bit, and this bit was 0. So now in 4 steps, I have reached this particular configuration. So now I want to set this particular bit. So currently it is 0, and let us assume that they are all 0 like this, right? So in this particular configuration, but you see, to reach this particular style, that the current configuration I have, it took me 4 steps. Now let us proceed from here. So now I want to make this to 0 again, right? Because I want this bit to be 1 and all the other bits to be 0 in order to change this particular bit, right? So I want to make this 0 again. So how do I do it? I'll have to make this 1. So it will take one step. So now total number of steps are 5. Then I can change this to 0. So this is 0. The total number of steps are now 6. I have to change this back to 0. The total number of steps are now 7. And now I can finally change this bit to 1. The total number of steps are now 8. Right. So you see that this particular value is depending on the current position. Right. So in order to make the ith bit, or to change the ith bit more specifically, I have to make 2 raised to the power I operations. Right. Considering that all the bits to the right of it are 0. Right. So that means, let me just write it more formally. So the most important observation in this particular problem is to change the ith bit, we have to make 2 raised to the power I operations considering all bits to the right of it are 0, right? And we are going to base our final solution on this particular observation. So how do we actually solve after it? Now you see that the input, let's say this is my input, the value is 10 here. Now if I want to calculate the number of steps required to make this particular bit 0, right? So I know that this is 2 raised to the power I, but only if all of the bits to the right of it are 0. but you see that this bit is 1, so I cannot directly calculate the answer. And in any other for any other value of n as well, there might be multiple 1 bits like this. So instead of going from n to 0, it would be very optimal to go from 0 to n, right? And let us see how we can do it. So going from 0 to n is always very easy, because now I will be sure that if I am setting this particular bit, I will always have all the bits to the right of it 0, right? So now I am going to go from 0 to n. So how do I do it now? I want to set this particular bit. So this is 0, 1, 2, 3, right? So I know that it is going to take 2 raised to the power I operations. That means 8 operations to change this particular bit, right? So now I change this particular bit, but you will always realize that it is going to be like this in the final configuration. Why? Because when I set this particular bit, this bit was also set, right? So in any case, you will see that here also you see all the bits are 0, but the current bit that I have set and the bit after it is also 1. So whenever I change this ith bit, I minus 1th bit will also be affected, and affected in a sense that it will be made equals to 1. But now in the final answer, I wanted this bit to be 0, right? I didn't want this particular bit. So now I again have to change it. So what will be the total number of operations? Considering that all the bits after it are already 0, I will take 2 raised to the power I operations, that is in this case 4 operations, to make this particular bit 0. So it will become 0 and the bit to the right of it is going to become 1. Now you see that it is exactly similar to the value of n that we wanted, and hence the total number of operations are 12, right? So the most important observation in this problem was that it is going to take 2 raised to the power I operations to make the current or to change the current bit, considering all the bits to the right of it are 0. Once you change the current bit, the bit to the right of it will become equals to 1, right? So this is very important. Now again, if you would want to change the current bit, you will have to apply the same operations. Now let us consider these 2 examples that are given to us in the sample. So 3 is like this. Now starting from 0, 0, this is 0th bit, this is first bit. So I want to change this particular bit. So how many operations will it take me? It will take me 2 raised to the power I operations, that is 2, right? So this will become 1 and this will become 1. Now this has become similar. So 2 will be the only number of operations that I need. Let us consider 6. So it is going to be 1, 1, 0. This is the 0th bit, first bit, second bit. Initially all of them are 0. I want to make the 0 into n. So I will take 2 raised to the power 2 operations, that is 4 operations, and then this will become 1, and also the bit to the right of it will become equals to 1. So again we have reached the final configuration, hence 4 number of steps. But since that is the reason why I took this particular example of 10, because the right bit becomes 1, but we didn't want it to be 1. That is why we'll have to change it again and we apply the same operations of 2 raised to the power I, right? So that is it for this particular problem. Now let us have a look at the code. So I've initialized my answer with 1, and I've initialized with this boolean variable with 1 as well, right? So this is going to denote whether my current bit is going to be 1 or not, right? And how can the current bit be 1? When the previous bit was changed. So let the ith bit was changed, then the I minus 1 bit is going to be 1 for sure, right? So I'm going from right to left, that is the most significant bit, to the least significant bit, because I know that I want all the bits to the right of my current bit to be 0. Only then I can apply this 2 raised to the power I wala formula, right? Now what I have to do is I have to check that whether my current bit is set or not. Let's say my current bit is set, right? So if my 1 is not true, that means if my 1 is not true, I'll have to change this particular bit and set my 1 is equals to 1, right? So what happened? I wanted 1, but I currently had 0, right? So I took this particular opportunity to make 2 raised to the power I operations. That is why I left shifted 1 I times. Now since this has become 1, the bit to the right of it will also become 1. So I mark 1 as positive or true. Otherwise, if 1 was already true, let's say I changed this particular bit, so it became 1, and this bit has become 1, and in the original answer or the value of n this was also 1, then I will not have to repeat this operation again, and hence 1 will be equals to 0 now, right? So I don't add anything to my value, but now 1 becomes 0, right? Otherwise, if the current bit is not set in the final answer and I have this 1 bit, right, that means I wanted 0, but I currently have 1, so again I'll have to make 2 raised to the power I operations to change the current bit. Once I change the current bit, This next value will also become 1, and hence I do not change this one variable here, right? So at the end I can just return my answer, and this would be the solution for this particular problem. So it took me some time to come to this particular solution, and I hope that you guys were able to understand it. So let me just quickly submit this. So you see it works very well as well, and again 0 milliseconds. And this was it for this particular video. If you guys were able to understand the solution, then do consider dropping a like on this video, and don't forget to share your thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.